Hello, this is the second video entitled Derivation Rules. However, this is actually the third video that teaches you or presents to you these derivation rules. Well, two derivation rules. And so we will today learn the product rule, which is defined as follows. So the derivative of f of x times g of x with respect to x is just equal to g of x times the derivative of f of x times the derivative of g of x plus g of x times the derivative of f of x. And so to see this formula at work, let's say that we defined f of x to be just x, and we multiply it times x squared, and we define that to be g of x. So this is actually x cubed, and we already know that the derivative of x cubed is 3x squared. But for the sake of this example, let's try to figure it out using the product rule and see that we actually get the same solution. And so first we have f of x, so that's x, times the derivative of g of x, and that's 2x, plus g of x, that's x squared, times the derivative of f of x, and that's just 1. And so we have 2x squared plus x squared, and we get 3x squared, which is the same thing. And so we have seen with this example that we get the same answer, and it's actually kind of easier. So other ways to use it is if you have, for example, two polynomials that you don't really want to combine because it might be difficult, and you can just get the derivative of each of them and then multiply it with the original factor of the other part. That didn't really make any sense, but let's work it out. So let's call this first one f of x and the second one g of x. So we have 2x squared minus 21x plus 3 as f of x, and then we're multiplying that to g of x, which we define to be 3x minus 1. And so first we have 2x squared minus 21x plus 3 times the derivative of g of x. So the derivative of 3x minus 1 is just 3. And so we multiply this by 3, and then we add it to 3 of x minus 1 times the derivative of f of x, which turns out to be 4x minus 21. And so as you can see here, it's a lot easier to combine then these two terms than to multiply these two terms and then get the derivative of them. And so that's just an alternative way, and it becomes a lot useful later on when you have really two functions that you don't really know how to combine, but you can just combine them in this way and it becomes easier. And so now we will learn about the quotient rule. So the quotient rule is, of course, the rule of dividing two, how to divide two functions. And so this is the rule. So the derivative of f of x divided by g of x. So I would like to note that in the product rule, you could actually just use f of x and g of x interchangeably. You could define either factor to be any one of those, but here it's very important that you keep the numerator as being f of x and the denominator as being g of x. And also, since here you're subtracting in the numerator of your derivative, you must make sure that your first term is g of x times the derivative of f of x, and that to that you subtract f of x times the derivative of g of x. If you turn it around, you would of course get the negative of the derivative, which is the wrong answer. And then to all of that, to that subtraction, you divide it by g squared of x, so g of x squared. And as an example, we already found the answer to negative 7 over square root of x. we found this to be 7 over 2 over the square root of x cubed. But just for the sake of the example, let's work it out using the quotient rule. And so, okay, sorry, I forgot here to define it as the derivative of. So they are not equal, only the derivative of this function is equal to this one, but not the function itself. Okay, so we have defined f of x to be negative 7. So f of x is equal to negative 7. We have g of x is equal to square root of x. Something very important to keep in mind is that g of x is not 1 over square root of x. G of x is the denominator itself, so that's just a square root of x. And so first we have square root of x, we have g of x times the derivative of f of x with respect to x, and that's just 0 since negative 7 is just a constant, minus, and we have negative 7 times the derivative of g of x, which turns out to be 1/2 times x to the negative 1/2. And we figured that out with the power rule. And then over that, well, we know that the square root of x squared is just x. And so we can just make this prettier, and we don't really need this first term. Negative times negative just becomes positive. And so we have 7 over 2 over square root of x, because here we have our x to the negative 1/2 times x, and so we know that this denominator is just equal to the square root of x cubed. And so in fact we found out that we get the same thing using the quotient rule, or in the case that we did before, using the power rule. Well, let's try a slightly more complicated problem. So let's say we have 3x minus 1 over 4x squared minus 4x. And so if we want to get the derivative of this, we do exactly the same we did before. So we have 4x squared minus 4x, because that is g of x times the derivative of f of x. In this case, it's only 3, minus f of x, so that's 3x minus 1, I'm sorry, times the derivative of g of x, which turns out to be 8x minus 4, over g of x squared, so that's 4x squared minus 4x squared, all of that squared. We could just try to simplify it, and you will get 36x squared minus 32x minus 4, all of that over 4x squared minus 4x, and all of that squared. And so never forget to say that this is the derivative of. It's not an equality if you don't define this, that we want to get the derivative of that. Okay, so that's the answer.